Hello everybody. Thank you for joining the InduSoft webinar covering OPC UA connectivity. Today we have a very special guest, Mr. Thomas Burke, President of the OPC Foundation. I'm Scott Courtier. I'm a technical evangelist for InduSoft. Today we're going to cover a little bit of overview of the OPC technologies that are within InduSoft Web Studio, give you a good OPC UA example and show you just how easy that is to configure, and talk a little bit about the connectivity options that you have with InduSoft Web Studio. And then I'll hand it over to Mr. Burke, who will cover some really good information about OPC, and then we'll open it up for questions and answers. For those of you who are not aware of the logistics that we do on these webinars, first of all, thank you for joining us. We really do appreciate it. But for those of you who are not familiar with it, we cannot hear you speak, so if you have any questions or comments, please feel free to add those into the chat panel or the Q&A panel within the WebEx, usually located at the top of your screen. After the webinar, Tom and I will answer questions about OPC, specifically OPC UA if we can, and how it affects you and how you can interact with it. Then look for, in a couple of days or soon, we will send out an email with links to the slides and a video recording on our YouTube or on our website. And then also look for that survey. And if you provide us with your name, address, and shirt size, we're going to send you a T-shirt just for joining our webinar. So just to show you we appreciate it and give you guys something back for joining. So let's go ahead and get started. First of all, I'd like to mention or announce that recently InduSoft Web Studio was certified in the OPC Foundation's certification lab for OPC Client. And I do believe, and Tom, if you can pipe up during your presentation, InduSoft was one of the first HMI and SCADA products that has been certified for client on OPC UA. So I think that's something very special. InduSoft has been a participant within the OPC Foundation since the early days, I believe 1998, and we're very active within this within the OPC Foundation. We participate in a lot of events with them. Here's some photos from an OPC Interoperability workshop that the OPC Foundation hosts. And what we do is we take our OPC solutions and we connect them up to other suppliers and vendors, make sure that we interoperate, can talk to each other, make sure that everything that we think should be working is working. This ensures that when you go to try OPC within our product, that it works as expected. We attend lots of trade shows, and Tom, I hope you don't mind, I stuck a picture in there of you with one of our application engineers from Germany, from OPC Day in Europe in 2011. Last year in 2012, I attended the IAS show in Shanghai, China. Tom, you were also there. So we're very active in the different seminars and different road shows that the OPC Foundation puts on, just to show that we can connect and show our support for this great technology, actually. So what does InduSoft Web Studio have built into it when it comes to OPC? Well, if we look back when we decided to go ahead and start working with OPC UA, this is one of the many technologies that the OPC Foundation has. OPC UA, we needed to be interoperable with different systems, different, for example, we're a client with servers, and it really needed to work with any operating system. Well, InduSoft Web Studio, runs on Windows-based runtime, so Windows or XP Embedded or even Windows CE or other versions of Windows operating systems were necessary for us to work. But OPC UA, as you'll see in Tom's presentation, is platform independent. We wanted our version to be easy to use, and I'll show you just how easy and quick that is in just a minute. I'll give you a demonstration. But another thing, and I'll show you in the next slide, is we also wanted it to be a gateway to other devices. We wanted to be able to get information from OPC UA into other connectivity connectivity options that InduSoft Web Studio has built into it. And last but not least, it certainly has to be secure. So for those of you who don't know what InduSoft Web Studio is, what OPC is, let's say that we have we have InduSoft Web Studio up here in the upper left-hand corner, and it wants to communicate to a PLC or some other device that has its own communications. Well, if you think of this as being two different languages, let's say English and Spanish, for example, or English and French, what you can think of is OPC is a translator for the languages in between. We don't have to know how to speak Spanish. We just have to know how to talk, in this case, OPC to the OPC server and let it handle communications to the devices on the other side. So we talk, for example, we would speak English in this example to the OPC server, and it would in turn talk Spanish. Well, of course, it's not English and Spanish. It's going to be, we're going to communicate the OPC standard to the server, and it's going to communicate a PLC protocol or a drive protocol or a temperature controller protocol on the other side. So we don't have to know what is on the other side. That's all we have to know is how to communicate OPC to the OPC server. And that's why the standards are so important. That's why these interoperability workshops are so important, so that we can use our client OPC technologies, and I'll show you these different technologies in a minute, to talk with OPC servers that match those technologies, and then it can communicate to the devices on the other side. So let's take this just a step further. So if you look at this diagram, we have InduSoft Web Studio communicating as a client to an OPC server, which in turn communicates to a device on the other side. Take a look at this diagram. I'm going to show it to you in the next slide and kind of show you a little bit more on it. So what did we want this to do? We wanted additional functionality, which would be gateway functionality, to complement other communications technologies. Well, what does that mean? Is we can use this as a gateway to get to other communication standards that InduSoft Web Studio already has built into it. Why is this good for you? Because it keeps your existing infrastructure. If you already have communications technologies that are out there, now we can get those communication technologies to OPC UA or communicate to OPC UA devices and then get those to your existing devices. So that using InduSoft Web Studio in that way. So let's show you this. So this is what I had on the other slide down in the bottom right-hand corner. This is the OPC server talking to various devices, and it could be any devices. It doesn't have to be PLCs. It could be temperature controllers, drives, building automation systems. There's a whole lot, and Tom will touch on the different types and quantities of devices in his presentation. So let's say that OPC server is communicating very happily to those devices. Now you'd bring in something like InduSoft Web Studio running on a PC or a Windows type environment, and using the OPC defined standard, we would communicate to that OPC server, where it in turn communicates to those other devices. Now, let's say that you wanted to get information from these PLCs, temperature controllers, and other devices to other communications devices that you already have. We could potentially communicate and store data from those devices into a SQL database. We could go communicate and hand that off to an ERP or an MES system. We could be communicating with one of the over 240 drivers that InduSoft has built into it to other PLCs or other drives, temperature controllers, for example. And last but certainly not least, InduSoft Web Studio has built into it the ability to get remote access on iPads, Android tablets, smartphones, even Internet Explorer 10 or Chrome on your PC or handheld device for that matter. So we have a whole host of ways to get communications from all of these different devices to OPC UA or the other direction as well. So what are the different options within InduSoft Web Studio? Current OPC Client Options, we have what's now known as OPC Classic, which is OPC DA. We support OPC DA 2.05 specification. We also support OPC UA in the product as a client, and OPC.NET 3.0. That's on a PC only, meaning that on these other two, we support them on our Windows CE and embedded environments as well. And last, we have OPC XML, and our our driver for this also supports DA, which you see up here at the top. This version of DA supports not only 2.05, but it also points to the 3.x specification as well. Something special about this, two things. Number one, it requires an additional license within InduSoft Web Studio, one of the rare occasions we require that. But the other thing is it allows you to multitask the communications, whereas the OPC DA 2.05 is not multitasking up here, or multi-threading, I should say. So let's talk a little bit more about OPC DA. In the previous slide, I mentioned all the different clients that we have. So those clients would communicate with typically third-party servers that are available on the market, so we could communicate to just about any device that's out there in the world. Well, this slide talks about InduSoft Web Studio can be an OPC DA server. So that also supports the 2.05 spec, and we've been testing this in all the different interop events since 2003. And what it does is it serves up the InduSoft tags, the system tags, the tags that you create within your application, and device tags, to other clients that would be requesting it. So just like an InduSoft OPC client can request information from another server, let's flip that on end and let anybody's client come and grab tag information from our server. So this is available not only for Windows PC, desktop, and server editions, but also from Windows CE and embedded editions as well. So let's now talk a little bit about the OPC Client Configuration, which OPC UA will be a majority of the focus of Tom's presentation. What does this give you? This includes item browsing capabilities, which I'll demonstrate here in a minute. It allows us to read and write on tag change and/or using triggers, so that it can be very fast and efficient. And we're going to show you the concept of connections, and we feel that this makes it very easy to use. So basically you create a connection, and then when you create a worksheet to communicate to that connection, if you have to change the devices or have to change what you're communicating to, that's all you have to do is create another type of connection, and you can completely change your entire infrastructure very easily. Not infrastructure, but what you're talking to in your infrastructure very easily. It does support security, both encryption and certificates, and it is available on Windows CE on our version 7.1 that's been out for a while now. So what is this concept of connections? We're going to name a connection first, and I'm going to demonstrate this here in a second, but first we're going to create a connection. I'm going to name it, and then I'm going to develop a worksheet that uses that connection, and then we're going to browse to those tags within that server, and I'll show you that here in just a second. So I'm sorry, I have a repeated slide here. So let's go ahead and demo what I just showed you before we hand it over to Tom. You should now see InduSoft Web Studio on your screen. This is our development environment, and what I'm going to do is I'm going to create a brand new project, and I'm going to choose the local interface here. And this is warning me that I already have a project named project, and I'm just going to go ahead and overwrite that for the sake of this webinar, prompting me for the resolution of what the display is going to be. And this is going to create a brand new blank project for us. On here I have no communications, I have no screens yet. The first thing that I'm going to do is, here you can see the different connections that we have for OPC DA, UA, .NET, XML, and DA. I'm going to create a connection to OPC UA. I'm going to drop this tree view down, and I'm going to right-click and click Insert. I'm going to name this my OPC UA. And now I need to establish the server that it's connecting to. Notice here that there's options for username and password and advanced security over here. This is where you would handle your certificates if you're doing that. So here I'm going to open up this browse, and now what this has done is this gives me what's called a discovery server, and this gives me the ability to discover or find the different OPC servers that I can connect to that are readily available to this PC. In this case, I happen to have the OPC Foundation's sample server running on my laptop, so I'm going to connect to that. Once I've done that, I just click on OK. Now I've got a connection to that. Now I'm going to go up here and right-click on OPC UA and insert a worksheet. Now this worksheet is what ties the OPC item names to the InduSoft tag names. Basically, it's just this two-column spreadsheet here, and we have some other things for scaling and how we scan those different tags. But that's all I really need to do here is say point it to my connection. In this case, it's the OPC UA or my OPC UA connection that I just created a minute ago. I don't have to fill in any of the information for statuses and whether or not I want to disable this. Those are all available to you, but for getting communications going quickly, I don't even need those. What I'm going to do now is down here in this cell, I'm going to right-click and browse to that OPC server. Now that I have that connection, this is reported back to us from the OPC server. This is not even a piece that's developed by InduSoft. This comes back to us, this information comes back to us from the server. So what I'm going to do is navigate down this tree a little bit, and we go down here to some scalar information, some dynamic information. I'm going to grab an integer value and say OK. And now what it's done is it's put that the information in that item name that I need to get to that piece of data right in that field. Now in here, I'm going to put an InduSoft tag name. Now I don't have any tags in here yet, but I'm just going to create one called temperature. And because I don't have a tag name, as soon as I hit enter, InduSoft Web Studio is going to prompt me. It says that tag doesn't exist. Let's go ahead and make it. So since I chose an integer 16 value, I'm going to match that up with our integer value. I could choose Boolean, integer, real, or string, but because we have an integer value coming from the OPC server, I'm going to choose that. That's made that tag on the fly. And at this point, I can save this worksheet. And at this point, if I was to run, that would be communicating from the OPC server back to that temperature tag. Well, let's show you a way that you can see this on the screen. I'm going to insert a new screen. I'm just going to keep all the defaults for my new screen. And I'm going to show you a bar graph. I'm just going to put a bar graph on here, tie it to, or put a rectangle and turn it into a bar graph with our bar graph animation. And here I'm going to tie it to the temperature tag. Because I don't want to type that, I'm just going to go ahead and browse that tag. And so I don't have to retype it. There we go. And I think because it's an integer that it's going to give us a value somewhere in the range of, I don't know if it's plus and minus, but we'll go negative 32,767 to positive 32,767. And colors, and let's make this a little bit larger just so we can see some of the big sways in numbers that we get. At this point, I can also use my database spy down here. And again, I'm going to mistype this, so let's just use our tag object finder here. We'll go in here and choose temperature. Right now, because I'm not running, the value is 0. If I run this application and then come back to my development environment here, you will see here that this value, once we get communications going, should be kick off here in the background. There we go. We got values coming in from that OPC server to the temperature tag. And now if I go back to my screen, you should be able to see those values updating in that bar graph. So it's just that easy. I mean, it really took me more time to discuss it and talk about it than it did to really create that. So I created my connection, I browsed to my item name, tied it to my temperature tag, put that temperature tag on the bar graph, and I was done at that point. So that's about as easy as it gets. And at this point, I'm going to go ahead and hand presentation status over to Tom. Tom, I have your audio enabled. Are you there?
I'm here. Wow, that was
all right.
That was an impressive demonstration, I must admit.
Thanks, Tom. Tom, you're a little bit quiet. I don't know if you got to pick up your handset there or.
Okay, is that better?
There, much better. Yep.
Much better.
Much better. Okay. I have made you presenter now. You should be able to go ahead and share your desktop, take that status over.
Okay. And the magic of technology should just be interoperable and work. If it was OPC, immediately.
There you go. I see your blue screen, so it looks like it's probably just adjusting for the different color variations and whatnot. So wait for your screen to.
Probably coming up now.
And there we go. I can see your desktop. And go ahead and launch your presentation. And I'll be quiet and mute myself. I'm handing it over to you, Tom. Thanks.
Thank you very much, Scott. Okay, my name is Tom Burke, and I'm the President and Executive Director of the OPC Foundation. And I'm very excited that all of you have taken time out from your busy schedules to learn more about OPC UA and also the capabilities and what InduSoft has been doing with the OPC technology portfolio. OPC started in 1995, and normally what I do at this point in time is when the live audience, I raise the hand and I pick on the person in the first row, sometimes the second row, and I say, "Can you tell me what OPC is?" But you guys get the luxury of not being asked the questions by me and put on the spot for asking these things. But essentially, OPC, when we started in 1995, was all about OLE for process control, and it was about the Microsoft technology, and as Scott attested to and told you what a client and server was and how it's essentially like a translator where the server knows how to talk to the underlying devices, and then it communicates via OPC to the client application, translating the information into a standard representation. So if you think about OPC, though, I really want you to think about how it's about innovation and about interoperability. And in the world of technology, how things are rapidly changing, and the expectations of the end user, everyone's looking for innovation and technology, and most importantly, out-of-the-box plug-and-play interoperability. The premise of a lot of things that we've been doing over the last several years, actually, is based on the expectations of the end users that they have with consumer electronics. And you think about the direction of consumer electronics and how everyone uses a smartphone or a tablet or many other intelligent devices, we're drastically moving into an environment where the expectations are I can just buy multiple products from multiple vendors and these things all just work. And they work reliable. And they should work reliable, and they should be secure, and you should be able to do all kinds of things, whether you're doing entertainment or you're graduating and you're gathering information and you're communicating information between applications or between people. And the premise of that is strictly all about the capability of what you can do with devices and what you can do with applications. So with consumer electronics and the direction we've been going in, the end users now that are industrial automation, they now have this expectation that, well, if it works in consumer electronics, why doesn't it work in industrial automation? So what OPC Foundation is really all about, it's about what I call the community, collaborating, and certification. When we started OPC, it was a community of vendors that were working together, essentially developing that first series of specifications that was driving the need for reading and writing data from devices and then translating that to the client applications. So if you think about OPC today, we've continued since 1995 with that same vision of a community of vendors, a community of end users, a community of consortiums, all collaborating together and building best-of-breed products that they then certify to make sure that the end users are happy. InduSoft is one of the key companies that I'm proud to present on behalf of today because they are committed to the OPC technology. They've participated in many of the OPC working groups, and they've been driving the technology. And as Scott said, they've participated in every interoperability workshop for the purpose of making sure that all their products work with other vendors. They know what it means to be multi-platform, or what we call multi-operating system. They understand embedded security, and really the collaboration and things that they've been working on lines up very well with OPC. And as Scott mentioned, yes, they were the first HMI product that was certified in the OPC lab, and they understand the need for plug-and-play interoperability. So what I want to talk about as we move forward on this is about OPC UA. When we started OPC, it was really about industrial automation, and it was very focused at providing the best technology for industrial automation. But over time, we recognized the need for how people want to really have information and data being exchanged from industrial automation to a variety of other domains, including areas like building automation and the embedded devices and anything with the word smart in front of it in the energy management arena. And I'm going to talk a little bit more about those when I get into the collaboration section. So if you look from a historical perspective of what OPC is, Scott talked about the client and the server. Well, before OPC, what happened was your favorite HMI vendor had to write a lot of complicated software to be able to talk to the underlying devices in process control and discrete applications. But with OPC, we standardize on a mechanism where the OPC server is the one that understands how to talk to the underlying devices, and all the upper layer applications, the client applications, just communicate via OPC to read and write data or read and write alarms or read or write historical information as the mechanism for interoperability. This really simplified the vendor's life. But the reality is, it not only simplified the vendor's life, it simplified the end user's life, because now they can pick and choose products that meet their needs, and they don't have to be tied to any single solution. So it's a good thing for everyone, both the suppliers and the end users. If you look at from a feature set of what we've provided by OPC, Scott demonstrated how easy it is to discover an OPC on a network, how easy it is to see the tags and the capabilities in the server, how easy it is to group some of these tags and be able just to click on these things and decide how to read and write more than one tag in a simple thing. Most importantly, though, it's all based on the concept of subscription, where a client specifies the set of tags it wants, and then the server provides the data on what's known as exception basis, so only when the data changes. What this really does is it provides a very seamless, high-performance way for moving data from the underlying server to the client application. So if you think about this from a classic perspective, we have the MES or the HMI OPC client application up here talking to the OPC server, and the OPC server is doing whatever it needs to do to communicate to the underlying devices. And if you could see this properly, what you would see is that the server is either receiving messages from the underlying devices or it's actually polling the underlying devices, but the client application never knows and never has to worry about the intricate details of communicating with the underlying devices. All it has to do is say, server, please tell me I want this tag, and I want this tag at this particular rate only when it changes. So life was good with what we call classic OPC when we started developing this in 1995. Everything was in the Windows world. We all love Microsoft, and I love Microsoft. And it was about Windows PCs, where the server and the client both ran on the Windows PC. That was based on an architecture of Microsoft called DCOM. And that worked well for the variety of things that we were doing inside of industrial automation. But then when we started to think about how do we move data across the firewall, we realized that that technology of what we're doing didn't provide a good solution for that at all. And we also realized that we have a lot of things that we want to do about configuring the devices and configuring the OPC server to be able to talk to the underlying devices, and many ways were coming out of the what I call the woodwork for doing that, which were not on Microsoft platforms for things. We also recognized, and as InduSoft has a multitude of products that are embedded, we wanted to have a way of communicating between embedded HMIs and PLCs, and in the typical case, they weren't running a Windows PC operating system, so consequently there was no standard or no way of doing that with classic OPC. We also wanted to do PLC to PLC communication, and again, that was very complicated to be able to do that because we were so tied to the Microsoft operating system. But the benefits of OPC, even though we were tied very much to the Microsoft, was that vendors no longer were required to understand the complex details of communicating to underlying devices. We had companies that would develop these high-quality device drivers to talk to the various equipment, and we were allowing and populating many, many client applications, allowing the end users to pick and choose from the products they wanted and make sure things just worked in a plug-and-play fashion in Microsoft. Over time, we continued to look at more and more things of what we could do with the classic architecture. And again, being very much, in love with Microsoft, we did things to solve the problem of alarming. We did things to solve the problem of standardizing historical data access. And as Scott mentioned, we also did some things with respect to XML that gave us the capability of moving data across the firewall in an internet environment. So that was the classic portfolio of things that we worked on, and life was good. We had a very wide adoption of the OPC Classic since 1995, and it's still being adopted now. We still get many companies that are building classic OPC products that are tied to Microsoft. So we have a very wide variety of products out there. As a matter of fact, there are both multitudes of products not only for industrial automation, but there are multitudes of products for other domains, including building automation, that are based on classic OPC. But in 2004, we started looking for how do we take advantage of this opportunity to look for what I call more scalable architectures and be able to look more at a service-oriented architecture such that we could think about having the OPC technology be platform or OS independent. And on the right side of the screen there, I start looking at the opportunity. We said, how do we get OPC data across the corporate firewall into the enterprise? How do we leverage and be able to communicate to the underlying embedded devices? How do we talk to SCADA devices that aren't necessarily on Microsoft? So we had to come up with a scalable architecture, which is part of the requirements for the OPC UA technology. We knew that we wanted to be able to communicate between a variety of distributed systems, and the importance of doing that is we had to have very good, secure ways of being able to do that, be able to cross the firewalls, still have high-speed performance, and then be reliable and robust and support the whole notion of platform independence in this kind of architecture. As we continued to develop this, we realized, we need to think about services, and we need to think about data, and we need to think about them as two different ways. So we came up with a concept of modeling data, actually building a type system that allows us to think about not only the objects, but the underlying data for all of the objects, and providing a very generic way for clients to be able to discover this information from a server and then be able to operate on that information. I'm going to talk more about the information modeling as we move forward. But at a very high level, the key features and benefits of the OPC Unified Architecture is all about cross-platform. I talk specifically about this so that you can have multiple ways of communicating with the same OPC UA technology independent of the underlying operating system. We wanted to take and unify the access for all the existing COM-based classic OPC applications, whether it was data access or alarms or historical data access, and be able to provide that such that a simple UA client would be able to operate and do data and alarms and history without having to understand the different ways that we had put together for classic OPC. And that's really the embodiment of UA. I talked about the importance of internet and firewall friendly. This is all about this, where a UA client can now talk across the internet to a UA server because we've standardized on the message, and we've standardized on the message on the wire instead of standardizing on a mechanism to communicate that was tied to an operating system. Standard security is now built in, and Scott highlighted some of the features that InduSoft takes advantage. The key things are encryption and certificates, and the ability to do authentication are all part of the basic benefits of OPC UA. So if you look at what we've done, we now have a single solution that allows you to take data and information from the embedded world all to the enterprise using the OPC UA technology. I told you that one of the great things with classic OPC was such wide adoption. Well, that also means that when we came up with UA, we had to make sure that all the investments that our vendors and our end users have made with the classic OPC architecture were protected such that they had the ability to leverage the classic OPC architecture deliberately. I talk about reliability by design. Reliability is built into the architecture very specifically, and I'm going to talk a lot more about the information model, but we have a very flexible object orientation model that allows us to take complex information from not only suppliers, but also for consortiums, and OPC UA becomes the transport and the discovery mechanism for moving that complex information. I want to highlight quickly again about this whole scalability and make sure that you remember what we're doing. It's all about OPC UA is the standard protocol that we use that allows us to communicate from the embedded all the way up to the enterprise. I like to say that I speak multiple languages, but the language that I'm really talking about are the programming languages. We have a API that's specific for C and C++, for Java, and also for the Microsoft .NET environment. The most important thing to remember, though, is that independent of the hardware and the operating system, we have total interoperability. I want to talk a little bit about how all this works and what we've done and how it's a single solution from the embedded to the enterprise. If you look down there in the circle, what classic OPC was all about was in a Microsoft network and a Microsoft operating system, an OPC client talked to an OPC server that understood how to talk to those underlying devices. But it didn't have a way of getting data or information into the planned information network. So this is where we had to go with OPC UA. From a communication protocol standpoint, we basically have what's known as 3 different layers inside of a client and 3 different layers inside of a server. And my slides will be available later, so don't try and scribble all this down, because normally in the audience everybody's writing it all down, trying to capture all this. But it's a very layered architecture. And deliberately, there's many ways for transferring the message at the transport layer between the client and the server. And we continue to add more protocols. Right now, we have our own UA TCP, we have HTTPS, we have HTTP, we have a binary, and we also have an XML for encoding and decoding across the wire. At the upper layer, from far as communication goes, there's actually application authentication and encryption and signing of the messages that allows for a secure way for passing information between the client and the server. And then at the application layer itself, we actually do user-level authorization and authentication and application authentication. So there's a variety of things that we've done, and the conceptual model for communication of OPC UA basically guarantees from a platform-independent platform operating system standpoint that you get the highest level internet capability, security, and reliability for what you're trying to do from an interoperable perspective. From a security standpoint, what this really means is that OPC UA has built in a simple security mechanism for authentication and authorization. We have application authentication, we have software authentication, we have user authentication, and we have user authorization. So we have multiple ways of doing and making sure that the client and server are secure. Since we decided to tackle the whole problem of platform independent, and everyone and their brother or significant other wants to have the ability to have their smartphone gathering data, we had to make sure that we had a highly secure system that really supports a whole model of integrity and confidentiality, which is based on a whole set of algorithms based for encryption. So there's a lot of things on this, and I'm covering just a very quick overview of that. But if you think about what we've said, from an application standpoint, you still have an OPC server that understands how to talk to those underlying data sources, whether they're for process or discrete or alarms and events or historical data or devices. And as Scott showed you in his demonstration with InduSoft Web Studio, the server is the one that understands and basically provides the address space of all of the things that you can access and communicate to. On the client side, it thinks of services, and this is just a partial list of some of the services, but what we've actually done with OPC UA, we've actually simplified and reduced the level of complexity that you typically had to do with classic OPC in order to read and write data. Now we have one read instead of 7 reads in the OPC data access architecture. So if you think of what I'm trying to do, we've unlocked and we've opened up the boundary between all these systems. I've been talking about the factory floor is no longer an island. We want communication. We want the ability to have data and information exchange between the enterprise and the embedded world, and that's the whole functionality of OPC UA. There's a benefit for the end users. The suppliers don't get a choice. They have to build security in. The end user gets to decide what's the appropriate level of security that you need for your installation. So with that, I want to talk and move into the next part of what's very important in OPC, and it's all about information modeling. The first thing I'd like to highlight is I talked about a community collaborating before, where OPC Classic was about a community of suppliers and end users. Now we're talking about a community of other standards organizations. So, for example, we talk about the Open O&M, or I talk about PLC Open, or I talk more about things in the oil and gas arena, or I talk about things in the upstream oil and gas, or I talk about BACnet. These are all the active organizations that OPC is actually partnering with, and we're developing companion specifications that allows their information to use the OPC services for generic client-server communication. So how does this all work? If you remember anything at all, the information model and what I'm showing you is that in that little green box down there on the bottom is where all the base level services are. So there's one read, there's one write, there's one subscribe, there's one discovery. And the information, which is separated from what we used to have in classic OPC, is basically the little building blocks that sit on top of that I call the OPC information model. More importantly than that, not only do OPC have its own information model for our information, we also have exploited and allowed the opportunity for vendors to add extensions and still have interoperability, so they can take all of their favorite data from their PLC or DCS and populate that and make it generically accessible by the clients. And we're also working very hard at developing specifications for the information models for some of the other collaborative organizations that I mentioned earlier. Underneath those base services is the transport and is the UA data model and how all the system comes together and why this is an architecture that we'll call being timeless durability, and it'll lack the test of time. So some of the key vertical markets that InduSoft has really been highlighting and working in are the same ones that the OPC Foundation is aggressively working with the other organizations to develop these complex information models. I'm going to talk a little bit about the machine builders and some embedded opportunities, the work in the pharmaceutical and the building automation and oil and gas as I move forward. So if you think about this and what I've said, the OPC Unified Architecture Specifications, the information for the OPC information model are those things that are in that orange. So like Part 8 is the data access and Part 9 is alarms and conditions. That's what used to be the OPC data access information from the classic. But the Part 5 information model is this whole generic information model access that allows us to create specialized information models for other domains and other consortium. So down below that you'll see we've created what I call the OPC UA for devices, which is a very generic way of modeling all devices and specifying all the behavior and all, mostly importantly, the objects and all the metadata behind those objects. One of the things that was derived from that was what's known as OPC UA for analyzer devices, which was targeted deliberately and worked on by the end-user community, essentially in the pharmaceutical, who decided they wanted a standard for analytical devices and analyzers, and that was the result of that. FDI underneath that is all about standardized communication for device configuration for a variety of field bus networks, including Profinet, Foundation Field Bus, HART, and FTT. And I'll talk a little bit more about that. So we continue to expand some of these specifications to address things. The IEC 1131 is the programming standard for PLCs. We've added a lot of functionality there. And what you'll see coming out very soon is the ability for generic communication from a PLC to PLC standpoint. So these are exciting things that we're doing at the device level. The box I just dropped in is what's known as ISA 95, and this is the mechanism that allows the enterprise applications to model the information at that layer to do asset management type applications, and OPC UA becomes the mechanism for communicating that information. I'll talk a little bit about oil and gas and just pick on a couple of these collaborations we're doing. One of the big ones that we've been working on is something that we didn't work on by ourselves. These guys came to us, and essentially all the major oil companies and all the major DCS vendors and the subsea vendors decided that they wanted to have a standardized information model for all of the devices involved in the subsea acquisition of oil. And one of the things they looked at from an OPC UA perspective is they wanted to have commercial off-the-shelf products, and the things that they were looking for involving communication of their information were all the same basic things that were built into OPC UA: subscription, security, reliability, and the whole concept of being able to model their information. One of the things that MDIS has been working on is they have a set of objects in the subsea world. They have a well, they have motors and manifolds and a variety of devices. I have no idea what they even are. But they're modeling all these devices essentially as objects in the OPC UA namespace, so there will be a companion specification that allows generic communication for the upper-level HMI clients to be able to communicate to these servers and be able to get complex information and the metadata behind that. So from an architecture standpoint, all of the oil companies have decided to collaborate together, which is interesting. So now we're talking about competitive oil companies working together in the interest of providing a mechanism for automation and interoperability. This is exciting, and it's exciting because these guys are looking for mechanism to reduce cost and be able to pick and choose products from a multiple set of vendors and do this in a platform-independent way. Sounds like OPC. So they selected UA as the protocol, and they're working right now very hard to define their complete information model, and we'll have a unified architecture companion spec probably early next year. I want to highlight quickly about ISA 95. This whole concept of 95, it didn't start in 95. That just happens to be the number. But essentially, ISA has been published a specification that basically defines all the resource models and a lot of the things necessary for asset management. In the enterprise world, they have a common object model for this. The big thing they were doing is all the what I call the role-based equipment and physical assets. And they want to take all this and be able to provide a standardized information model, and they're using and have developed an OPC UA companion specification. So now a client can connect up to one of these servers that understands ISA 95, and you can truly use the OPC UA services to get that information. So this is just kind of a high-level overview of this. We've got multiple vendors and that have actually been building and prototyping this. This is the first time it's an exciting thing that we've heard from the end-user community about the value proposition that this really brings forward to them from an interoperable perspective. So I won't cover too much more on that. The next one I want to jump into a little bit is about what's known as drilling system automation. The Society of Petroleum Engineers have been working together for a period of time, and they wanted to look for opportunities to do automation in drilling for the oil and gas community. This is different than the subsea that I talked about with MDIS. Now, this is at the surface level, where they're looking at the variety of things in order to be able to do automation of drilling to really do a more effective way and be able to leverage and take advantage of the vast amount of information that they have to allow them to figure out the next place to drill and maintaining of all that equipment. What happened with this is there's a lot of things that are going on in this with relation to drilling, the different things that they're doing in order to do effective drilling, knowing where they're drilling and maintaining this equipment. And I learned a lot about drilling in terms of the cost of some of these drills. These are not the drill bits that you buy from Home Depot, for example. These are expensive pieces of equipment. And the most important thing is they want to have good information about this equipment in order to maintain the equipment effectively, and so that they can do things that are highly preventative rather than being a reactive strategy. So part of this whole concept is they're looking at all these different devices in terms of drilling systems, and they're going to be able to take these hole openers and motors and be able to look at all this information and be able to measure the information and essentially have objects and metadata behind that really we use the OPC UA protocol to be able to communicate. Big thing, again, is the operators. It's all the oil companies are involved, the drilling contractors, the equipment suppliers, and the service companies. And notice that these are the guys that are doing all the collaboration, developing, actually, objects for all of their information and metadata behind this that then will be modeled using the OPC UA technology. So what they looked at is this makes it simple, commercial off the shelf, it's secure, and essentially it's compatible with many of the SCADA systems that are already out there. They're basing it on an existing standard that's been popular for over 10 years in the drilling industry right now, which is called the Well Information Transfer Standard, more affectionately known as WIT-SML. So this is another good opportunity as you're thinking about what is OPC UA used for? Well, it's being highly used to discover and communicate complex information in the oil and gas and all the way through the enterprise. So those are kind of exciting things there. From a machine building standpoint, MT Connect is kind of the universal factory floor communication protocol, and MT Connect is a subsidiary of the AMT organization. They looked at using OPC UA specifically, and an MT companion specification has been developed essentially for device manufacturers leveraging the capability of the MT Connect standard that talks specifically to their device hardware to be able to have a generic way for reading and writing data and subscribing. This is the beauty of OPC UA. It fit their model very well. They came up with a lot of things they wanted to do, from independent software vendors being able to communicate to a lot of these different devices using the MT Connect application and their objects and talking to the underlying devices in the machine building technology. So most importantly, one of the things they were interested in is they want to gather information and have this information available in the cloud, and having a lot of historical information available in the cloud. So the importance of secure communication across the internet, and also having control between different devices and a network configuration, which is all the base architecture of OPC UA. So those are some exciting things there. The next thing I want to just move a little away from industrial automation and talk a little bit about some of the collaboration that OPC is doing in building automation. And my friends at InduSoft have been very active in building automation for a lot of reasons, and I want to talk a little bit about that. So essentially, BACnet is what I call the global standard for communication and building automation systems. They understand all these different building automation devices. BACnet is the standard for defining and communicating information between those devices. It really specifies the representation of all the objects in the variety of field-level devices in the building automation arena. The BACnet interest group in Europe is responsible for promoting BACnet in the European markets, and OPC has deliberately partnered with them essentially to create a mapping model for OPC UA and all of the BACnet objects. So if you look at that little picture over there, there's the BACnet objects in the repository, and we want to create a hierarchical OPC UA information model that allows generic servers to be able to configure and pull this together, and then generic clients will be able to access that information. The first thing we've done is we've looked at the whole concept of data from the building automation standpoint, things that I call that are energy metering data or real-time information like weather and temperature type devices, and we want to provide that level of information and describe those objects such that we have the ability for the enterprise system to be able to operate on that information and be able to store it. And that's one of the big things we've done, mapping the BACnet objects to OPC UA. The other side of the coin, though, we recognize we've got a unique opportunity to actually map the OPC UA objects into BACnet. So all the data from your typical automation systems, production information, all the variety of PLCs and DCSs that are in building automation, and a lot of things that we're doing in smart energy can now be communicated using OPC UA and modeled into the building management systems for things like facility monitoring and so forth. So this is an exciting opportunity of what we've been able to take care of. So if you think of OPC UA and what we're doing and the feature summary of it, essentially OPC UA incorporates all the OPC Classic specification into one standard. So we've taken all the feature functionality and the information of data access, alarms and events, historical data access, the capability of doing programming, and we have a single set of services in UA, and then we have the building blocks of the other data for the classic OPC architecture. Vendors now can support one technology. So instead of having to know data access and alarms and events and historical data access, they know OPC UA, and they just plug in the information models of data access and alarms and condition in HDA. We've got complete backwards compatibility with all the classic OPC products out there. But as you can see, a couple things that I've highlighted in OPC UA, it's about security, it's about reliability, it's about the capability of doing complex information modeling in a platform independent strategy. So we take the best things in classic OPC, and now we can take all that, and we still have all the best things in classic OPC, but we've added a lot of significant performance enhancements, platform independence, and additional functionality that really provides a whole strategy for interoperability from the enterprise all the way down to the embedded world. So from the embedded products, I'm proud to say InduSoft is one of the leaders in developing the embedded HMI products, and Scott talked about that. We've got a lot of products that are coming out from the suppliers, in the PLC and DCS world, in the 1131. There's a multitude of vendors that have hosted OPC UA on a chip. We're doing a lot of things with communication gateway, and most importantly, we're expanding the reach of interoperability into areas like building automation and mapping all of those BACnet objects. At the SCADA level, it's strictly about, the capability of developing a cohesive system of components that all work together. So I can take my favorite SCADA HMI and be able to talk directly down to the OPC UA server and be able to talk to the multitude of devices. But now I can get a lot more information from those devices than I could with classic OPC. And that's an exciting part of the whole information model. If you think about what we've done in the MES world and the enterprise, now you can have an OPC UA server directly embedded in a device, and up at the engineering level or the enterprise level or the MES level, they can get information, not just data. They can get complex information about what's going on in the underlying parts of the control system across the corporate firewall. So that's an exciting part of the UA. So in summary, one of the things I want to cover is, why do suppliers and end user care? Because the reality is consumer electronics and the expectations in consumer electronics where you buy products from multiple vendors, you now want to be able to do the same thing in industrial automation and have this whole information integration and reliability and security. So it actually lowers your cost of ownership because now you can pick and choose the best products that meet your needs. And it's about multi-vendor. It's about multiple products from multiple vendors. It's about this whole concept where I talk about expectations of products working right out of the box in a multi-vendor scenario. I talked about information modeling. Think of a world of I take 10,000 digital photos and all of a sudden I want to find my favorite ant and I want to find all the pictures that have my favorite ant in it. Good luck. Good news is now we have facial recognition, which actually stores metadata in every one of those given digital photos that can now help you be more intelligent about operating on that data. It's about plug and play, not plug and pray. The whole concept of certification and the demonstration of what my friends at InduSoft are doing at making sure that they have the best quality interoperable products that are well certified. So last thing, remember the picture, it's about Linux, it's about Microsoft, it's about the Android, it's about the iOS, it's about all this different proprietary operating system. OPC UA is about platform independence and scalability, allowing you to move data and information from your favorite supplier's products independent of the underlying platform and operating system. So with that, I'm going to turn it back over to Scott, and I know he's dying to do another demonstration probably, and take all your questions on things that are going on in the world of OPC UA and InduSoft connectivity.
Tom, thank you very much. Really appreciate it. Great information. For those of you who don't know me, I've actually been using OPC products since the late 90s. I think 98 is probably the first time I touched an OPC client and server, and it amazes me of knowing what really goes on in the back end and a lot of the stuff what you just showed and how simple it can be made. I mean, it's certainly a testament to the OPC Foundation as well as to the InduSoft development guys. But thank you, Tom. Appreciate it. I'm going to open it up to questions. Again, for those of you who are not familiar with our logistics here, we can't hear you. So if you have questions, add those into the Q&A or chat panels. What I'm going to do here is one of the things I forgot to demonstrate earlier is that we have an import wizard that we can actually bring in from an OPC server. We can import the item names directly from that. So for example here, I'm going to show you all the different OPC servers that I happen to have installed on here. Now this is supporting OPC DA. I'm going to point to a software toolbox top server that I have installed. And this gives us the opportunity when I import these, I could add a prefix at the beginning of the tag name if I wanted to. So I could call this OPC or PLC1 if I wanted to. I could insert whatever I wanted to in there. So this gives me the ability to import those tags directly. Now what this is doing is it goes out and it reads all those item names, and then it shows me, oh, wait a minute, there's an item name called time. Well, that conflicts with the tag called time that's already within InduSoft Web Studio. So you can see it's highlighted as red and unchecked. So it gives you a way, and I'm just going to cancel out of this, gives you a way to bring in all of the tags or all the item names from an OPC DA server if you needed to. Again, Tom, I want to thank you. Here's a question that just showed up. How easy is it to make InduSoft a client? Let's see. All of these within InduSoft Web Studio, this DA 2.05, UA.NET, and XML/DA, those are all the clients that we have. So as I showed earlier, just by creating that connection and then establishing the worksheet that ties the item name to the temperature tag, in this case, that's how easy it is to make the clients. I'm wondering maybe if the question was more maybe about the server. Here we can go under tasks and we can turn on, we have OPC HDA server as well as InduSoft can become a DA, what we call the Studio SCADA OPC server. So that's all you have to do is start that task, and then other clients can then come and browse our tag names as items. So hopefully that answers your question. Let's see. Okay, so the clarification just came in. Yeah, server. So that's the question that I just answered, which is you just click here on tasks and go here and start the server. That's all you have to do. Some other questions that came in. Tom, if you can quickly, what's the best way to find out OPC compliant products? The specific question came in for how can you find out compliant products for building automation, but I'm going to generalize it and say, where can I find information if I want OPC products?
Scott, the simple answer to that, and thank you for asking the question, whoever did. The compliance products are actually hosted, the information on the OPC Foundation website, and there's a section specifically that talks about the whole compliance program and certification program, and there is a certification logo that all of the vendors that have a certified product are then allowed to use. But simple answer is go to opcfoundation.org and go under the certification tab, and you'll find the list of products that have been certified by the OPC Foundation.
Great. Tom, thank you. I want to thank you again. I really learned something every time I see you present. Even from the morning session to the afternoon session, I learned something. And I can't tell you the countless presentations that I've been in with you. Again, I'd like to thank all of our attendees. There's no more questions in the queue, so we're just a few minutes over, and I'd like to thank everybody for attending today. Again, you're going to get an email with links to the presentations and the recorded video, and please fill out the survey. Let us know how we're doing. If you give us your name, address, and shirt size, you're going to get a t-shirt just for joining us today. So at that, Tom, again, I'd like to thank you.
Thank you, Scott. Thank you all, everyone, for attending and participating.
And we're going to end the webinar. Thank you, everybody, and join us again in just a couple of weeks. Thanks.